Yeah, good afternoon, one and all. I'm myself, Dr. Sharma Vittapu. Today I am going to demonstrate a back propagation algorithm. This is the most important algorithm for the neural networks. Okay, what is the back propagation going to be discussed? I'm going to give the small scenario. Suppose human brain going to be work different times and different situations. Okay, for example, I am going to throw certain type of dart, for example. Each and every drop, first time I am going to throw the so and so thing, that will give us one type of result. Second time I am going to throw the same drop for the same distance, may increase, the distance may be a decrease. Okay, according to that situations, what is the brain, that going to be work? Okay, for example, first time there is no other things are available, that your brain is working properly, perfectly. Second time, something may be disturbed by the so-and-so mind. At the same time, something may be added to the so-and-so mind. At the time, your results are maybe satisfied, may not satisfied. Okay, this the basically depends on the things where particular things are not suitable, where particular things are suitable. Such type of identification going to be done by introducing a back propagation algorithm for the neural networks. Okay, before going to be that, this neural networks basically followed by a human brain. Okay, how this human brain will work. Okay, sometimes certain situations humans are going to be forget about the things. Okay, what is the way to collect the so and so things which are already happened? Okay, that is also same as it is. What is the human brain after 5 minutes, after 10 minutes, after read something, after collecting such a type of experience? Okay, he may recollect it and he may continue with the so and so process. Same process, that is called back propagation. Okay, back propagation is called as an algorithm, or you can say that is called technique. Basically, wherever things are happened, those things are not satisfied, whenever come to the back and apply the so and so things, then modified it, then continue with your process. Okay, then we'll see the what is the definition of the back propagation here. Oh, okay. Here, back propagation is the two mechanisms are available. Before going to be that, the deep learning back propagation is exactly that the process. What is the process is? How that human brain going to be work. Okay, what is the behavior of the so-and-so human brain? Okay, that human brain may be a disturb, may not disturb, or something according to situations that's the thinking capabilities are keep on changing, or thinking is stable, or thinking capabilities are keep on changing. These are the many factors are going to be affected by this. Each and every factor need to find by introducing back propagation algorithm for the so and so neural network. Okay, the basic back propagation is exactly that the process. What is the explain to you? That is how the brain going to be work at all. Okay, it is the backbone of the how neural networks. Okay, there are several types of networks are available. For example, if you take a forward propagation, at the same time backward propagation. Forward propagation is only followed by the one direction. That means wherever inputs are available, those inputs are going to be forwarded to the so-and-so processor. The processor may be updated and outputs are generated by the so-and-so thing. That is called unidirection. Okay, whenever back propagation is there, set of data is available, in that which data may be a possible to modify it, which data may not satisfy, which process may not require, which may require to modify certain things. Situations, forward propagation never going to be work at all. That's why this back propagation is just like a feedback mechanism. Okay, feedback. Wherever errors are identified, immediately those errors are going to be updated and forwarded to the particular process. Okay, that is called. Here forward pass is the network taking its best guesses. Okay, that is called 100% that will come. But whenever modifications are going to be done by the so-and-so human, at that time this is not possible. Okay, that's why back propagation is the pass. This is basically followed by a feedback mechanisms. Wherever errors are there, wherever things are there. Okay, then another one is the Back propagation is a neural network propagation is the technique used for learning which adjusted the weights. Okay, for example, if you take a straight line, okay, here suppose if you take a straight line, okay, this straight line followed by some fixed coordinates like 0, 5. Okay, this is called fixed parameters. Okay, this going to be continued for the particular duration. Okay, after that, this straight line keep on changing. Okay, that is called another coordinates are going to be added. This add mechanism is called weight between the nodes. This is called starting node. This is called ending node. Okay, wherever I need to add the weights to the so and so thing, the behavior, the thinking capabilities are, the results are keep on changing. Okay, that is required. Yeah. Okay, the continuation of this back propagation basically followed by the gradient descent. What is meant by this gradient descent is, suppose for example, y is an output, x is an input. Okay, in between wherever y2, that is called w2, w1, w2 is there. Okay, this w1, w2 is called is an weighted. Okay, suppose for example, x I am going to add the w1. Okay, w1 going to be added to the w2, w2 going to be added to the y. Okay, that's why whenever you need to change the so and so things, this is the structure going to be followed by the back propagation. Yes. Then second one is, what is the way to calculate the back propagation method? That is called gradient of the so and so law. The main understanding of this is you need to find the loss. Okay, how much loss going to be done by you? Okay, first time you are going to be do, that is called 0.1%. Second time, that is called 0.2. Third time, that is called 0.3. Keep on adding 0.1, 2, 3 like that. Certain time, certain point, this is going to be becoming into an integer. Okay, that going to be more errors are possible for this. Okay, that's why the main intention to introduce the differentiation between each and every iterations. How many times rates are going to be changed? How many times the results are not satisfied? How many times the results are generated successfully? Okay, that's why this is the back propagation is depends on that one. Then this is the another method. Forward propagation is only followed by the one direction. Already I told you. Okay. Already I told you like this. Okay. This propagation is always change the weights whenever is required. That's why this is called a bidirectional mechanisms. Once you can observe the so-and-so diagram here, reverse engineering from y. That means results are not satisfied. Immediately come to the so-and-so weighted. That is called H1, H2 like that. Okay, once here also not satisfied, that going to be extended with X1 and X2. Okay, both are going to be combined it and then will going to be successful the so and so things like that. Then another one is here each and every stage what is the changes are. This going to be appear to the so and so users. Okay, suppose y I am going to change, x I am going to change, other y1, y2 going to be changed, like everything is going to be appearing to the so and so user. That's why this mechanism is always supports for the 100% transparent to the so and so users. Okay, this is the formula, mathematical formulation of the so and so back propagation. The differentiation between input, output, in between can keep on changing the weights until satisfied by the so and so user. Okay, then here the comparisons of forward pass and backward pass is, okay, forward pass is compute activations, the fast activations is x forward only one direction, then output errors are very less errors comparatively forward. Why? Because that is the only followed by the single direction. Okay, whenever come to the back propagation, okay, the errors are somewhat more comparatively forward because of keep on coming and going and modifying and updating, everything is that will come under. That's why use the transpose of the weight matrices wherever changes are required, wherever already changed by you, wherever need to change. These are the three aspects are followed by this. Use the transpose of the so-and-so weighted matrix to push the so-and-so error gradients backward through to the hidden layer. Okay, that is. Another one is Before close the so conclusions of the mechanism back propagation, keep in mind the propagation is not always perfect. Okay, the back propagation is always not a perfect. Your network is too deep. Okay, that's why many things are available, many elements are available, many elements need to modified. Okay, according to that situation, this is going to be preferable. Okay, deep and you use the wrong activation functions also there. There was, for example, instead of directions, okay, I'm going to change the so X, but by mistake, I'm going to give the so Y, that's going to be affected. That means entire results are going to be wrong. That is the basically drawback of the so back propagation. Until unless there is no awareness of so things like that, immediately that's going to be affected by the entire system. Okay, that finally that model going to be fail. Okay, that is also one of the reason. This is known that harnessing the gradient problem that prevent early layers from the learning. This is why modern deep learning heavily relies on the so functions. That is called randomly efficient. What you call that is called LU. LU is nothing but linear units. Okay, wherever linear units are there, this back propagation algorithm is very perfectly suitable for the particular situations, right?